All right, hello everyone. My name is Austin Erickson. I'm a student down in Florida at the University of Central Florida in the Synthetic Reality Lab. Today I'll be talking to you a little bit about a survey we ran about visual perception related research in optical see-through AR. So as AR researchers, we all kind of have this dream that one day we'll be able to use these devices all over the place, how we use our smartphones right now. So this means being able to use them in a very wide variety of contexts and locations, everywhere where we typically use our smartphones at the moment. Now, in order to do this, that means that we need to make devices and software on those devices that allows us to see what we need to see under so many different lighting conditions and so many different, general conditions like static versus dynamic environments. So we're hoping that we reach this, and we're making some steps towards this at the moment. We've seen some pretty cool headsets come out over the last few years that give us our first steps towards this dream. But anyone who's used, one of the HoloLenses or the Magic Leap one knows that they're not perfect, right? There's still a pretty big set of conditions under which it's difficult to see the virtual content that it's trying to show us. And part of this is because they all use what's known as the additive light model. They're adding light into the user's view of their physical environment. So because of this, colors like black or dark blue become very transparent and appear kind of how you see in the screenshot when you're using an optical see-through device. And even the white colors tend to become transparent to a certain degree as well, which is why you can see that brick colored background in the image here. And in reality, it's actually a little worse than this depending on the user's environment. If you're in a particularly bright environment, the contrast is going to be greatly reduced just because the luminance of the display can't really compete with the luminance of the sun. So you get a very washed out looking image that is very difficult to see. They're not perfect right now, and we know that more devices are going to come out probably in the near future that improve with each iteration. But it's still probably going to be a little while before we reach that perfect hardware solution that lets our users see the virtual content in that widest set of locations and contexts. So this is kind of what motivated us to do this survey, was trying to figure out what we can do in the meantime to make virtual content appear its best to our users under the widest set of locations and contexts that are possible. So of course we need to know what has been done and what's left to do in this area. So far we did a survey on the IEEE and ACM digital libraries. We cast kind of a wide search net with general search terms. So while we returned almost 350 papers, we narrowed this down to about 14 at the end. We were able to classify these 14 papers after reading them in detail into 8 major categories. So these categories were split into kind of 2 groups. The first group was based on their research area, what they were focusing on in the paper, and the second are kind of their research methods. So for the research area, we had the first 4 on this list here. Text enhancements like billboards, text outlines, text drop shadows, papers that investigated that. Also papers that investigated the effects of lighting and contrast on the user's perception and performance. We had papers that were looking into different color combinations for UI and how that affects the user. And then we also had a set that was looking at text location and text size and its impact on the user. So in addition to those, we were looking at a couple research methods. For instance, what type of users did they recruit for their studies? What was the specific application area? What was the specific type of headset and display parameters that they used? And then what type of study did they run? Was it like a traditional user study, or was it more of an engineering study where they were making repeated measurements with like a luminance meter on the device? So once we tagged and classified everything, we reached this colorful graph here. Each of the colored sections represents each of those 8 different categories, and then each of the individual bars is a more specific tag that falls under each of those categories. So I'm not going to go through all of these at the moment, but if you're interested, please do take a look in the paper, and I'll highlight just some of the key areas here. So one of the biggest areas that was tagged in the paper's return from the survey were dealing with text enhancements and contrast polarity. So the questions that they were trying to answer here are billboards where you have a solid colored rectangle displayed behind the font. Are those better than plain text or vice versa? And then with contrast polarity, of course, a traditional style UI would have black font on a white background, and we'd call that light mode or positive contrast. And the reverse of that would be dark mode, negative contrast, or light colored font against a dark background. So these papers were all trying to investigate which types of UIs tend to perform best. Interestingly, the results here were rather inconclusive. We saw a couple of papers that supported that dark mode UIs tend to produce better user performance, and a couple which suggest that light mode was best. We had a couple that said that billboards were better than other things such as plain text and drop shadows and text outlines, but then we also had a couple papers which said that plain text was better. So I'll come back to this in a little bit, but there was a very wide variety of different devices that were used in the user studies in these 14 papers that we found. So we believe that some of this is due to differences between those devices. So another main category, kind of a research area, was investigating the foreground color and background color, or the background appearance of the user's physical environment. So how do these factors influence the user and their perception and their ability to use these UIs? And an interesting thing that we noted here was that we saw 4 different studies where red colored UIs were rated pretty bad for user performance. It just didn't keep up with the other color combinations. This was interesting because it kind of goes against your intuition here. People do have cones on the back of the eye that are specifically tuned to the red wavelength. So you'd expect that because we're able to pick up on that color so easily, that it would yield pretty good performance in optical see-through displays. But this turned out to not be the case in 4 different studies, and only one study had a red colored UI that performed pretty well. The other thing was about visual complexity and visual noise. You'd expect that with low complexity, as you see on the bottom here, like a solid colored background would be easier to read and would produce significantly better user performance than a more visually complex background like what you see down there in the bottom right. There were 2 or 3 studies that looked into this, and they did not find any significant difference in visual complexity, which kind of goes against what you would expect. Another thing that was commonly looked at under the same area was about color blending. So I mentioned earlier that optical see-through displays have this issue with transparency. So if you have blue text against a white background, it's not really an issue. Your text is still going to appear blue and slightly transparent. However, if you change to a different color background, such as red, what happens is that you're now seeing the combination of that red background and that blue text, which is added on top of it. So the resulting image appears kind of like purple text over a red background. So this was picked up in a couple different studies that users do notice this change in color. And then, interestingly, there was a method by Insebe Ramos et al. That showed that you can actually correct for this sort of thing if you're taking into account what the user's physical environment looks like. Another big research area was in environment lighting and contrast. And this kind of goes exactly how we mentioned at the beginning. There were several studies that involved different illuminance levels for several of their conditions. And in general, what was shown was that as that illuminance level increases, the contrast that the users see between the UI and the background is reduced, and users tend to perform worse as that increases. So this is really to be expected. So after going through all the details here, we did notice a couple general trends between all our papers as well. One of them, as I briefly mentioned earlier, was about the optical see-through hardware that was used in these papers. So 4 papers used monocular displays, 8 used stereoscopic displays, and 1 used an in-vehicle heads-up display. So in total, there were 10 different devices used between the 14 different papers that we had in our survey. And of course, each of these different devices has its own different luminance capability and its own different color capabilities. So this does make it really difficult to compare the results of all of these different studies. This is going to continue to be an issue since there's definitely going to be more optical see-through devices on the horizon here. So one thing we need to consider moving forward is how we can compare the results of previous studies with the studies we're running in the near future. And to do this, that means we're going to need to take luminance measurements on the displays to get an idea of what users are experiencing there, as well as luminance measurements of the testing environment to know exactly what the light level in the environment is, as well as screenshots or pictures of what the environment looks like. Interestingly, one paper in our survey dealt with dynamic backgrounds. So they had video clips that were played on a prop behind the virtual content that they were showing on the display. So that is really the context that people are going to be using optical see-through headsets in hopefully the near future, right? There's not very many contexts that involve static backgrounds, static physical environments. So of course, us as researchers designing our studies, it's easy to test against the static backdrop because we know we're getting the same thing for each participant in the study, but it's just not what they're going to experience in the wild when they start to use these headsets. So an interesting problem that we'll have to address is how dynamic 3D physical environments impact users' performance and their perception of this virtual content. It could be that their preferences change, or that they perform better with a slightly different UI configuration than they would in that static lab environment that we've currently been testing in. And then one last interesting trend here was about participant demographics. So of course, we all typically recruit from university student population. So most of the participants in these studies were, mid-20s in age, had normal visual acuity, and had normal color perception. So this is great. This does count for a pretty big portion of our general population, but there are going to be users that have visual conditions when these devices are made more public and more readily available. There's things like color vision deficiencies, decreased visual acuity, and age-related things such as presbyopia, where you lose your ability to accommodate to near distances, that can all have effects on how users perceive content on these devices and how they perform with certain UI configurations. So it could be in the near future that, at least for the subset of users who experience some sort of visual condition or visual deficiency, they might need a slightly different UI configuration than what works for the rest of the general population. So that's all I have time for, but thank you so much for attending my talk. I will be around to answer any questions. Otherwise, feel free to email me at the email shown here. Thank you. Bye.